Okay, so we're going to look at some exponent laws. And what exponent laws really are is just an alternate way to work through numbers so that if you're faced with order of operations, you can recognize that you don't always have to evaluate the exponents first in terms of what order of operations says. It gives you some flexibility to work with your numbers. And so you can also see that I've got it as investigating exponent laws. This is a perfect way to practice your investigation skills. And so I've set it up so that it leads you a little bit, but you should be able to create your own general rule working through it. And so I'm going to talk you through a couple of pieces, and I would just ask that when it says hit pause and to complete the work, that you go ahead and do so. And then once you hit play, I'll either have everything filled in for you or I might talk through a couple of other things. Okay, so the first exponent law that we're going to look at is product of powers. And so you can see that I've got this organized as our expression. And we've got it in expanded form and then a simplified expression using powers with the same base. So the same base, I mean, as the base that we've got in our original expression, and then the product being what our answer is. So expanded form. So think about, what does 2 cubed actually mean? Well, 2 cubed is 2 times 2 times 2, and times 2 squared is 2 times 2. So when you take a look at that, how can we rewrite that as a power? So you can see that we've got 5 2's being multiplied by itself, and so it makes sense that it is 2 to the 5th. And if you work that out, we're talking about 2 times 2 times 2 times 2, or we talked about last time, even being able to group them. So if you look at that as 8 times 4, we can quickly see that our product is 32. So take a moment and complete the rest of the table and see if you can create the general rule on your own, describing what it is that, what pattern you see. Okay, so hopefully you had hit pause and filled in the rest of the table. If you did not, then hit pause now and rewind it a little bit and fill in your table, and we can compare some things that you should notice. One, when we expand, you can see that I've identified what the base is in each case, base being directly below the exponent or everything inside brackets. In some cases, I'm showing multiplication using the times symbol. Other cases, I'm using a dot to show multiplication or parentheses. And then we've got our simplified expression and our product. If you notice the one with 7 to the 6th, that is definitely outside of the parameters that I gave to you in terms of what you need to be able to calculate on your own without a calculator. So I'll admit, yes, I also used a calculator to figure that one out. So take a look and at the pattern that's created. And so our goal is, how do we get from our expression and end up with a simplified expression? So if I see 2 cubed times 2 squared, how do I know it's 2 to the 5th? If I see negative 2 all to the 4th times negative 2 all cubed, how do I know it's negative 2 all to the 7th? And so on. So take a moment, hit pause, and see if you can create a general rule. Be specific with your math terminology using base and exponent, and you're going to talk about it in words. And then afterwards, see if you can create a general rule using some variables for your base and your exponent. Okay, so once again, let's hit pause and come back and compare. Okay, so some key words then. So we want to make sure that we've got, when multiplying powers, and they have to have the same base. If you notice in this last example that I gave to you, we didn't have the same base, so when we expanded all out, it wasn't something that we can combine as a single base. So when multiplying powers that have the same base, we're going to keep the base and we're going to add the exponents. So those would be the key pieces that you would need in your general rule. So algebraically, what might that look like? Well, perhaps we have something like x to the a times x to the b. So you can see that I've got those key pieces in here. I've got multiplication. I've got myself multiplying two powers that have the same base. In my product, our simplified expression, I'm going to keep that base and add those exponents. Okay, so just like you would normally do with an investigation, you want to try to verify. So part of the verification is testing your rule and coming up with examples that certainly support your rule, but in the back of your head, you're also saying, okay, how general is this? Can I break my rule perhaps as well? So work through and see if you can come up with some 3 different types of examples and see what we end up with. Okay, so these are the 3 examples that I came up with. So something a little bit different. And I said, okay, what if the base was a fraction? And does that make any difference? Well, we know how to expand it. If the base is everything within our brackets, so we can expand it. I've got 2/3 squared, so 2/3 times 2/3 times 2/3 cubed, so another 3 2/3 multiplied together, and you can see 5 2/3 all there, and so it's 2/3 all to the 5th. That's something that you should be able to do without your calculator, or you'll work your way up to that. So multiplying all the way across, so 2 to the 5th is 32, and 3 to the 5th is 243. Well, above we had examples where we had multiplying 3 factors together, so something like the 7ths. There were 3 pieces to that, and what if there's 4? Does that make a difference? And you can see clearly that it doesn't. The last example, whoops, I actually wrote something different than what I had meant to do. So the last example I wanted to write was -2 cubed times 2 squared. And so on the one hand, I hope that you're saying to yourselves, whoa, time out. Those bases aren't the same. However, what do we recognize is at the end of the day, it's a bunch of 2's being multiplied together. So we know that the answer is going to be the same as 2 to the 5th, except it's a question of whether or not it's positive or negative. And so when we expand it, and you can see 3 negative 2's being multiplied together and 2 positive 2's, what do we know is we've got 2 to the 5th, and then the answer is going to be negative because there's an odd number of negatives. So while this -2 to the 5th doesn't expand out to be exactly the same as -2 cubed times 2 squared, it will give us the same answer, so it would be acceptable to write it in that way and then to recognize that our product is -32. And so that is product of powers. And so we'll have you do the same thing for a couple of the other exponent laws. And so I'll just stop this one right here and go on to the next one.